Okay, in this video we're going to be looking at how to find the vertex and how to find the equation for a line of symmetry when we're looking at a quadratic that's written in vertex form. Now this is part of power standard number 12, and like I said, it's only part of this standard. This standard is a pretty comprehensive standard, so to try to cover it all in one video would be a little much. So we're going to break this up into a couple of videos, and so this is going to be the first part that's going to cover just parts A and B of that power standard, which are covering the vertex and how to get the equation for the line of symmetry. So let's start by looking at what is the equation for the vertex form of a parabola. The equation for the vertex of a parabola is this. It's y minus k equals a times x minus h squared. Now the reason we call this the vertex form of a parabola is when it's in this form, it's really easy to find the vertex, because you can also see that our vertex is a coordinate. It's going to be a coordinate. We call this coordinate the x value h and the y value k, and it's embedded in that vertex form. So it's going to be y minus the k, which is the y value of the vertex, equals a, and we'll talk about that a in another video, times x minus the x value, or the h part of your vertex, that quantity squared. There's also an equation to recognize that we need to know, is the equation for the line of symmetry. What is the line of symmetry? Well, let's look at a diagram here. This diagram is showing us a parabola, and the vertex, you can see, is that point at the it's going to be either a minimum or a maximum value. If the parabola opens upwards, that vertex is going to be a minimum value. If it opens downwards, that vertex is going to be the maximum value. But we talk more about that again in a different video. But that line of symmetry is where, if you look at that parabola, it's going to be the same on both sides. So it's reflected over that line of symmetry. So that's essentially, and the equation for that, if you recognize, it's a vertical line, and we've talked about vertical lines in the past, but a vertical line is in the form x equals something. So it's going to be x equals whatever the h value is of your vertex. Very easy. But you want to make sure that you recognize that it is an equation. You're not just writing down, if you have a vertex where the x value is -2, the equation for the line of symmetry isn't just -2, it's x equals -2. So it's important to recognize that we're looking for a formula here. So let's look at some examples. So this first one, these are all in vertex form. Y minus 2 equals x plus 3 quantity squared. So to find the vertex, if we were asked to do that in this problem, to find the vertex, again, the vertex is a coordinate h and k. And this is in the form y minus k equals a times x minus h squared. So a very easy way to find out what the vertex is remember the vertex is a coordinate. The x value of that vertex, the h, to find out what that is, we look at the equation in vertex form, and you find your x in that vertex, or find your x in that form. So we look here. There's your x. So we look at what's happening with the x. We're taking x plus 3. So an easy way to find the x value in your vertex is you take the opposite of what happens to the x here. So the opposite of adding 3 would be to subtract 3, or have a -3. So our vertex here would be the coordinate -3. And then to find the y value of the vertex, guess what? We look over at the y over here, and we look to see what's happening with that y. Here we have y minus 2. So the opposite of subtracting 2 would be to add 2. So the y value of our vertex is a positive 2. So our vertex is the coordinate -3, 2. Let's see what the line is, or the equation for the line of symmetry would be. The equation for the line of symmetry would just be x equals -3. It's that simple. Okay, why don't you guys try this one on your own, the example number 2, where we have y plus 4 equals 1/2 times the quantity of x minus 6 squared. Don't let that 1/2 fool you. We really don't need to use that right now. We'll use that for something a little later on. But for the purpose of this problem, we don't need to use that. So pause the video and hit play when you're ready to check to see if you have the right answer. Okay, you should have done this one already now. So our vertex here, remember, we look to see what's happening with the x. Here we have x minus 6. So the opposite of subtracting 6 is a positive 6, or to add 6. So the x value of my vertex is 6. My y value of my vertex is going to be the opposite of what happens to the y, which is a -4 in this case. So my vertex is the coordinate 6, -4. So the axis of symmetry, or the line of symmetry, is going to be x equals whatever the x value is in my vertex. So it'll be x equals a positive 6. So there's my equation for the line of symmetry. Now sometimes there is another way that we could write our equation to be in vertex form, and that looks like this. If you notice, the y is by itself, and we have equals 2 times x plus 7 quantity squared minus 3. What we're going to do here is we're going to, there's a couple ways you can look at it. We could add 3 to both sides, because if you notice right now there's nothing going on with the y, but we have that minus 3 on the other side. That's kind of different from what we've seen. We could add 3 to both sides, so we have y plus 3 equals 2 times x plus 7 quantity squared. And now it looks like the previous problem. So now to figure out what the x value is in our vertex, we would just take the opposite of a positive 7, that's a -7. And we look to see what's happening with the y here. Y is, we have it plus 3, so the opposite of that would be a -3. But if you notice, that -3 is the same as what we had here originally. So it really wasn't necessary for me to rewrite this. If you recognize this, you could see that if we were to add 3 to the other side and then end up taking the opposite of it, we're back to where we started from anyhow. So if you see an equation in this form, you still take what happens to the x, take the opposite of that, but then the part that's kind of dangling there in the end, that -3, you can just leave that the same, and that's the part that's the y value of our vertex. Because another way that you could look at that equation for a parabola in vertex form is this. It'd be y equals a times x minus h squared plus k. And that's essentially what we have here. Why don't you guys try this one on your own? Let's say if we have y equals -3 times x minus 4 squared plus 5. Why don't you see if you can figure out what the vertex is from this? So if you need to pause the video, do that, and then hit play when you're ready to check your answer. Okay, if you do this one, if you work this one out, and if you use that trick that we just talked about, you can see that the x value of your vertex would be a positive 4, because we still take the opposite of what happens to the x, so it's going to be a positive 4. But since I have that plus 5 on the end, that's my y value for my vertex, so my y value would be 5. And we didn't talk about the line of symmetry going back to the previous one, but if we had to find the line of symmetry there, it'd be x equals -7. The line of symmetry for this one would be x equals 4. So that's how we find the vertex and the line of symmetry when we're given an equation in vertex form. So hopefully this made sense to you, and good luck on watching your other videos.